Hello everyone, am I audible? Yeah. So, am I audible? Let me check. Okay, my dear friends. So let us start today's lecture. Yes. So yesterday we studied this. Yes. So yesterday we studied half of the SHM, right? And today we are going to continue it. Okay. So let us continue this chapter. Okay, SHM, and this is revision part two, right? So we are not going for the detailed lecture today. We are just talking about the important concepts and that's all some questions. Okay. From Monday, I am going to start the complete syllabus from kinematics to entire physics, and after that, 12th class like that. Okay. So let us start. Okay. So at first, I would like to welcome you all. Welcome to Unacademy. Unacademy is the India's largest learning platform where you can prepare for the various competitive exams with the help of the top educators of the country with the quality content and great learning experience. So let's track NEET UG. I am Rahul Dagariya. I have been teaching physics since 5 years in the various reputed institutions of India. Till now, I have mentored to the thousands of aspirants of NEET and IIT JEE, and now I am available here to help the students of the country to learn the concepts of physics for NEET UG with the best notes and best examples. So, let us talk about our new anthem. We want you to crack NEET UG with India's largest learning platform, Unacademy. So, if you want to crack NEET UG with us, get the subscription and study with the India's top educators. Yes, Unacademy will provide you the India's best educators. If you did not download the Unacademy app yet, please go to Play Store and type Unacademy Learning app and download it. After that, what you need to do? You need to get the plus subscription. Okay. So what you will get? You will get the daily live classes, right? You will get the quizzes, then structured courses, right? So all things, these all facilities you will get. So you can see here daily live classes, this structured courses, and unlimited access to the live and recorded courses, right? So structured courses means the entire syllabus. You can chat with us. Okay, you can discuss any concept with us. You can ask your doubt, right? And you can evaluate your performance with our test, right? So that's all. These all facilities you will get. Let us talk about our free classes are available on YouTube. Okay, and after that, our top educators are from IITs, NITs, AIMS, and reputed MBBS colleges. Okay, and now I'll talk about Unacademy subscription. So you can see our subscriptions are available for 1 month, 12 months, 24 months. Okay, like that, 3 6 months also there, but I am just introducing this, right? So 1 month fee is 6,000 rupees, 12 month fee is 30,000 rupees, and 24 month fee is 36,000 rupees. If you see 6 months, that is 24,000 rupees. But if you use my code RAHULD, Rahul D, if you use this code, you will get the 10% discount. So for 1 month, you need to pay 5,400. For 6 months, you need to pay 21,600. For 12 months, you need to pay 27,000 rupees, and 24 months, you need to pay 32,400 rupees. So you can see this is equivalent to 5 month fee, and this is equivalent to 6 months fee. Okay. So definitely this is very cheaper than any other coaching institute, and you are getting so many facilities, including the test series. So which one is beneficial? Obviously, 12 month or 24 month subscription is beneficial for you. Okay. So let us talk about our today's topic, simple harmonic motion. So half of the chapter we have studied yesterday. So that part I am going to skip today. And today's part I am going to start, that is spring mass system. Okay, spring mass system. After that, pendulum, right? Simple pendulum, compound pendulum. These all things, right? So let us start. Let me come to that slide. So that slide is coming soon, and it is here, spring mass system. So my dear friends, let us talk about spring mass system. What is a spring mass system? So let us talk about this. Yeah. So I am using yellow ink. It will be more comfortable to see, right? Yes. So you can see here one block of mass M is there on a frictionless horizontal surface, and a spring is connected to it with a ball. Okay. So now what will happen? I will just displace this block. So spring will extend and I will release the block. So what will happen? After that, this block will come back. It will go. So back and forth, it will just execute an oscillatory motion without any loss of energy. So that type of motion is called simple harmonic motion. Okay. So for such type of spring mass system, what is the formula of time period? The formula of time period is T is equals to 2 pi root of m by k, right? I am not going to explain the derivation today because this is a revision lecture, so we'll move accordingly, right? Yeah. So this is the first question. What is the time period of SHM of spring mass system, right? Yeah. So this is T is equals to 2 pi root of m by k. That's all, right? Next, if the same system is hanging in a vertical plane from the ceiling, so I will say the gravity is acting downward. Gravity is acting downward. But still the formula of time period is same, that is 2 pi root of m by k. So for both the system, either it is horizontal or it is vertical, right? Doesn't matter. One mass is there, one spring is there. So definitely its time period will be what? T is equals to 2 pi root of m by k. Remember, what is the angular frequency for this system? So angular frequency omega is equals to under root of omega is equals to under root of k by m. Omega is equals to under root of k by m. What's happening? Sorry, something is wrong here. I'm not getting what's wrong. Okay, just a minute. Now it will be solved. Yes. So we can use this simple formulas, right? Okay. So T is equals to 2 pi root m by k. That is just for the spring mass system, either it is vertical or horizontal. Okay, so omega is equals to under root of k by m, and T is equals to 2 pi by omega. That is 2 pi, sorry, 2 pi under root of m by k. So simple, these formulas you need to remember, this one and this one. That's all. Okay, so let us move to the next slide. So next, if spring is also having mass, in the last formula, spring was massless. But suppose spring is having mass and the mass of the spring is ms. Mass of the spring is ms. Then the formula of time period will be T is equals to 2 pi under root of mass of the block plus mass of the spring divided by 3. Okay, divided by k. So same formula, T is equals to 2 pi root of m by k. But here instead of m, I will write m plus ms by 3. Ms is mass of spring. Okay, how it came? Definitely it will come from the integration and derivation, right? But here we don't need, we will just move. Directly just remember the formula. That's all, my dear friends. So this is the formula you need to remember. 2 pi root of m plus m by 3 upon k. So that's all. This is the formula of SHM of a spring mass system where spring is having mass ms. Okay, that's all. So let's say I have a question for you. So I just wanna ask a question. So I'm just deleting this and I'm asking you a question. The question is, yes, the question is here. Let's say mass of the spring is 3 kg. Okay, mass of the block is 3 kg. Mass of the block is 3 kg. Okay, after that it is given that the spring constant is 900 newton per meter. Then what is the formula of time? What will be the time period? This is the question I am asking you. So four options in front of you. 2 pi root of m by k. Okay, second option B is sorry, let us write the value of m. So 2 pi root of 1 by 10. T is equals to 2 pi root of 1 by 10. First option is this. Second, 2 pi under root of 1 by 30. C option, 2 pi by 15. And D option, none of this. Which of the following is the correct answer for this? Okay. Yes. So which of the following is the correct answer for this? You need to answer this question as up. Okay. So that's all. This is a very simple question. So I am going to erase this and I will solve this question now. Okay. So let us start. I'm going to solve it at the top. So T is equals to 2 pi under root of mass of block plus mass of spring divided by 3 upon K. K is 900. So let us write its value. So 2 pi under root of 3 by 3 is 1, right? So this is 4 by 900. Okay. If it will come out of root 2 pi, this will become what? 2, and this will become 30. So directly answer is what? 2 pi 2 pi root of 2 pi 1 by 15. So this is the answer. The option is the answer. Got it? That's all. Very very simple calculation. So 2 pi by 15 second is the answer. That's all. So very simple question, right? So let's move to the next slide. So I hope you are getting it, you are understanding it. So I will talk about this next question, right? So next question in front of you, very very important question, my dear friends. Yes, nice. So C is the correct answer, my dear Don. Dinesh Don. Okay. So question number 7. Let us talk about this. Friction coefficient between two blocks as shown in the figure is mu. Okay. So let's say these two blocks are there. So friction coefficient between the blocks is mu. Between the surface and block is not present. Like between surface is smooth. Are you getting? Surface is smooth, but friction coefficient between both the blocks is mu. Okay. Now, if the system is slightly displaced and released, so system is just brought this side and released. Okay. So suppose there is no relative motion between the blocks. Both the blocks are moving together. Suppose that. Okay. So find the time period of this system. So you need to find the time period. So what you are getting from this? Simply speaking, remember T is equals to 2 pi under root of m by k. So the time period of spring mass system depends on m and k. Mass of the system into spring constant. It does not depend on gravity. It does not depend on gravity. It just depends on mass and spring constant k. It just depends on these two quantities. That's all, my dear friends. So you need to remember it. Okay. So I am erasing this, and now I'll draw the diagram. Yeah, so this is the spring constant K, and now it is connected with this block. So its mass is capital M. Small block is placed here, small m, and here's friction coefficient is mu. Here no friction. Okay, so directly we need to find what is the time period. So simply speaking, there is no slipping. Both are moving together. So so means both the blocks are considered as a system. So mass of the system is what? M plus M. So formula T is equals to 2 pi under root of mass of system. So M plus M. Okay, upon k 2 pi under root of m by k. That's all. That formula only I am using. So the time period of this for this system for the simple harmonic motion is T is equals to 2 pi root of capital M plus small m divided by d. This is the first question. Up now the second question, my dear friends, very very important. Okay, so you can see the question number A is done. Question number B. Find the magnitude of the friction force between both the blocks when the displacement from the mean position is x. So my dear, it is given that let's say these blocks are brought this side, okay, and displacement is given, that is x. How much? X. Okay. So now you have to find what? You need to find the friction on the block. So this is small m, this is the capital M. So I will say at displacement, at displacement x. Okay, acceleration is what? Omega square x. All of you know that, right? Yesterday only I taught this thing. Displacement x hai, then acceleration is omega square x. Okay, so what will be the friction? So I will say the acceleration this side. So I will just make the free body diagram of small block. This small block is having acceleration a this side. How this acceleration is coming? This acceleration is coming because of friction force, because there is no any factor which can give motion to this small block. Only the friction can give motion to this block. So what I will write? F is equals to, okay, m into a, है ना? From the Newton's law, F is equals to ma. So friction is equals to mass into acceleration, because this is only providing acceleration. So what will be the value of friction? Mass is m, acceleration is omega square x, and what is the value of omega? Omega is equals to under root of k by total mass. Under root of k by total mass. So I am writing omega here. under root of k by total mass. Total mass is m plus small m. Let us write it here. So I will get m into k divided by m plus small m, right? Into x. So that's all. This is the value of the friction force acting on the block. That's all. So this is the answer. Okay. All of you can do it, right? So let us move to the third question, right? What is the third question? Third question is, what can be the maximum amplitude of the upper block does not slip relative to the lower block? Okay, if upper block does not, upper block does not slip relative to the lower block. So what will be the amplitude? You know? So you need to find amplitude. So simply speaking, the same question this is, we all know one thing. This block will accelerate because of friction. So this was because of friction. So I will say at limiting condition, friction will be limiting friction. So that is mu into mg. Okay. Next, this acceleration is coming because of this friction only. So directly I will write F is equals to mass into acceleration. So mu mg is equals to m into a. Sorry. So mass is m, okay, or a. A can be written as what? Omega square into x. But a maximum for f maximum, you need to write what? A maximum into m. Yani ki f is equals to m into a. Acceleration will be maximum, then friction will also be maximum. And all of you know, a maximum is equals to omega square into capital A. Means the value of x is equals to a, right? Because x is maximum at amplitudes, right? So the acceleration is also maximum at amplitude. So here I will write omega square into a. I need to find amplitude. So let us find it. Let us cancel this m to m. So a will be equal to mu g upon, okay, omega square. That's all. So this is the simple answer we are getting. Let us put the value to mu g, and this will be omega is equals to under root of what? K by m plus m. So let us put this value. So we'll get under root k is there, and here we'll get omega square. So no under root. There will be direct k upon m plus m. So m plus small m, no under root. Okay. So this answer we will get, right? Mu g into m plus m divided by k. So this is the final answer we are getting for the third question. Okay. That's all. So I think you are getting it. Let's move to the next question. Very, very simple, right? So let us talk about this next question. So here you can see a block of mass small m, okay, it is moving like this, and it will move and it just hit the another block of mass small m, है ना? The one block of mass m is hitting another block of mass small m, है ना? And there is a spring having spring constant k. Spring is having spring constant k, right? So you need to find time period of SHM if both the blocks stick with each other after, yeah, it is written here, right block, and it stick to it. Okay, so they will just stick to each other. So I will say initial momentum was m into v, right? So what will be final momentum? So let's say final momentum, both the blocks will move together. M into v1 plus m into v1. Both will have same speed. Hi Hydra Dynamo. Okay. So, yeah, m1 v1 plus m2 v2, है ना? So both mass are same and both will have same velocity because both will move together. So directly I will write this is 2mv. 1. Okay. So initial momentum I have written, final momentum I have written, and you can see first block is just hitting the second block, and both will collide with each other. Both will collide and stick with each other. So they will become a single block. Okay. Whenever such type of event happens, we can say during the collision, momentum of the system remains conserved. So initial momentum will be equal to final momentum. Initial momentum will be equal to final momentum. So let us put the value. What we'll get, m into v will be equal to 2mv1. That's all. So we are getting the value of v1, means final velocity of the blocks, that is v by 2. What? V by 2. So we are getting the final velocity of the block. Now what you need to find? You need to find the amplitude. So you know, initially the spring was at relaxed state. So whenever spring is at relaxed state, the blocks will have maximum velocity. So the maximum velocity is what? V1, and that is V by 2. Now next thing, Vmax, you know the formula of Vmax, that is A omega, amplitude into omega. This formula already you know. So let us put the value. The value is V by 2 is equals to A, amplitude, right? Into omega. So what will be the omega for this? Two blocks are there. Omega is equals to root of K by M. Means K by, here two masses are there. So K by 2M. So this is the formula of omega you will put here. So you will get root of K by 2M. Okay. So let us simplify it. You will get the answer. So the value of amplitude will be what? That will be root of M by 2K into V. This is the answer. This is the final answer you are getting from this question. So this will be the amplitude, final amplitude, right? Okay. That's all. Very, very simple question. All of you can do it. No need to worry about it, right? Okay. So similar question I would like to ask you. One more question I would like to ask you based on the same concept. Okay. So I'm just erasing it. Now the question is, let's say this mass, is 2m. How much? 2m. So let's say this mass is 2m. Then what will be the uh, amplitude of resulting motion? Okay. So at first, time period and amplitude, both things we need to find, let's say. So time period, at first I will find omega. Omega will be equal to, when both the blocks will stick to each other, so omega will be equal to what? Root of K by M. Means K by total mass is 3m. Okay. So this will be omega. So what will be the time period? So the time period will be T is equals to 2 pi by omega. So 2 pi under root of 3m by K. So this will be time period. Now initial momentum is what? That is 2mv. Final momentum is what? So this block will go and stick to the second block. So the total momentum will be 3m d1, because these blocks are sticked with each other. Okay, that's all. So they will stick with each other. That's why their speed will be same and total mass is 3m. That's all. So I will say momentum will remain conserved because there is a collision. Okay. So 2mv will be equal to 3m v1. So we are getting the value of v1, that is 2v by 3. That's all. So we got the value of v. Now what we need to find? We need to find the amplitude. So we all know Vmax is equals to A omega. All of you know this formula, right? So let us put the value. So value of V max is what? This only, right? That is 2V by 3. That is amplitude into omega. Omega is what? K, root of K by 3m. So root of K by 3m. So let us write its value. So what we will get? So amplitude we will get what? Let us solve it. Right? So we'll get 2V outside, and this is m by 3k. Like this we will get. If we will simplify this answer we will get. So that's all. This is the answer for this question. That's all, my dear friends. Okay. So it's over. Let's move to the next question. Okay. So the question in front of you is, a system is in equilibrium. Initially it is in equilibrium. Okay. And at rest. Now the mass m1 is removed from it. So now the mass m1 is removed from it. So what will happen? As you will remove the mass m1, so equilibrium position will be changed. So here, so it will come up and then go down. So it will come up, go down, like that. It will execute SHM. Okay. Find the time period and amplitude of resulting motion. Okay. And spring constant K. So time period will be what? Initially time period is 2 pi root m1 plus m2 upon K. The initial. So 2 pi under root of m plus capital M divided by K. What will be the final time period? That will be 2 pi under root of small m1. Matlab m1 is removed. So we will get m2 by K. Okay. That's all. So we are getting answer like this. Time period we have done. Okay. So 2 pi root m2 by K. Now we need to write. I think you are not able to see this, right? Okay. So what is the time period? So T will be equal to 2 pi root of final mass is what? M2. So M2 divided by K. This is the answer for time period. Now, what is the amplitude? So listen, how to do it. This is the spring. Initially it is here. So this block is M1. This block is M2. So M1 and M2 both are here. So what is the extension? So all of you know, let's say extension is X1. Initial extension is X1. So I will write kx1 is equal to m1 plus m2 into g. Equilibrium, no? So both the forces will be equal. So x1 initial extension, that will be m1 plus m2 into g divided by k. So this is the initial extension of the spring. Okay, now let us talk about the final extension. So finally what will happen? Only and only one block, that is m2. So finally only m2 is there, m1 is not there. So I will say final extension is x2. So I will write k into x2, that will be equal to m2g. Why? Because m1 is removed from the system. So I am getting x2 is equals to m2g divided by k. That's all. So this is x2. So I need to find amplitude. So amplitude is what? Amplitude is just the difference between both the equilibriums. You know? So amplitude will be equal to maximum displacement minus the final equilibrium position. So maximum displacement is what? Maximum displacement is this x1 and final is x2. So if you will minus it, you will get m1g divided by k. Means remove the mass into g divided by k. So this is the final amplitude of the SHM. Okay, so we are getting the formula for the SHM, value of amplitude of SHM. Okay, that's all. Right, this is a simple thing I wanted to explain you, my dear. So let us talk about next, series combination. Okay, so now I will talk about the combination of spring, right? So at first, series combination, when two springs are connected in such a way that a spring is directly connected with second spring. Okay, so if two or more springs are directly connected, let's say it's spring constant k1, it's k2. So this is called series combination. It is called series combination. Okay, during the series combination, if massless springs are used, then I will say tension in each spring. Tension in each spring will be same. So tension in each spring will be same. Okay. Next, what else? The both the springs will have different extension. Tension is same, spring constant is different, so different extension. So x1 will not be equal to x2 for this. Okay, so these are the 2 points you need to remember. For the series combination of the spring, you need to remember the extension will be different, but tension in each spring will be same. Okay, right. Next, what is the k equivalent? K equivalent means equivalent spring constant. So that will be 1 by k is equals to 1 by k1 plus 1 by k2. Remember this. 1 by k equivalent is equals to 1 by k1 plus 1 by k2. If you simplify it, what you will get? K equivalent is equals to k1 k2 divided by k1 plus k2. So this is the formula you need to remember, my dear friends. Okay. Yes. So now what will be the formula of time period? So T will be equal to, let's say here is the mass M. So T will be equal to 2 pi under root of M upon K equivalent. Okay, that's all. So you will get the answer for this question. Okay, right. So this is the formula you need to follow. That's all, my dear friends. So I'm going to delete it and I will, just a minute. Yes. So what you need to do? You just need to use this formula. Okay. So series combination. You can see this series combination. Tension will be same. Extension will be different. Okay. Now, what is the formula of time period? T is equals to 2 pi root of m upon k equivalent. What is the value of k equivalent? K equivalent will be equal to 1 by k equivalent is equals to 1 by k1 plus 1 by k2. Okay. That's all. So finally, yeah, these are the things you need to remember. That's all. So I'm going to ask a question. A question for you. So I am writing, let's say there is a spring having spring constant. Having spring constant, this is 3k and this is 6k and this is mass of 8m. Okay, find the time period. Find the time period of oscillation. You need to find the time period. So I'm giving you some option. T is equals to 2 pi root of m by k. B option, T is equals to pi root m by k. C option, 4 pi root m by k. And last D option, pi by 2 root m by k. These are the four options in front of you. You need to choose the correct answer. So which of the following answer is the correct? If 8m mass block of mass of 8m is connected with two springs K, sorry, 3K and 6K in series. So answer will be what? So I will write K equivalent is equals to K1 K2 divided by K1 plus K2. You know what will be value? 3 into 6 divided by 3 plus 6. Okay, so the answer will be what? 18 divided by 9 means 2K. So K equivalent is equals to 2K. What was the formula? T is equals to 2 pi root m by K equivalent. So let us write here 2 pi root of m. Value of mass is how much? You can see here 8m. So I am writing 8m divided by K equivalent, that is 2K. So we are getting what? We are getting 2 pi under root of 4m by k. है ना? This 4 will come out, so it will become 2. So we will get answer 4 pi root of m by k. So which one is the answer? So C option is the answer. 4 pi root of m by k is the answer. That's all. So very simple question. All of you can do it, right? So let us move to the yeah, one important concept. Listen, I want to explain you because this is very important for me. Listen. So I am saying I have a spring. I have a spring. So this is a complete spring. Its natural length is L. Its natural length is L. And spring constant is K. Okay. I will cut this spring into two equal parts. Okay. I will cut this spring into two equal parts. So let's say this is first and this is second. So its length is L by 2. Its length is also L by 2. So its spring constant will be K1 and its spring constant will be K2. So remember one thing. For any spring, K into L is always constant. Okay, यानी कि spring constant into length of the springs are always constant. Okay, this multiple is always constant. So let us write the value. So initially K into L, that will be equal to K1 into L by 2. That will be equal to K2 into L by 2. What will be value of K1? So you can see LL cancel. K1 is equals to 2K. What will be the value of K2? The K2 also 2K. That's all. So like that you can find the spring constant of each segment of the spring. Okay, right? So I hope you are getting it right. So very simple concept. Okay, so remember this. For any spring, K into L is equals to constant. Remember. So next is parallel combination. My dear friends, what is parallel combination? Parallel combination is a combination in which each spring is connected with the block directly. Okay, individual springs are connected with the block separately. Remember this. Okay, if block is displaced by x, so each change in length of each spring will be x only. Okay, change in length of each spring will be x only if block is displaced by a length x. So I will write what? So I will see the second diagram. There are two diagrams for the uh, parallel combination of spring like this. So you can see in first diagram, if I will displace this M block this side, so both the spring will have same extension X. Okay. So I will say the force will be different, but extension will be same in each spring. Next, if in second diagram, if first block is displaced like this, so one spring is having X extension, second will have X compression. The change in length is same only. Okay. One is having compression, another is having extension. Okay. So that's all. So we need to remember the formula. K equivalent should be equal to K1 plus K2. What is same? So we will say extension or compression means change in length is same. Change in length of spring is same. This thing you need to remember, my dear friend. Okay, what is different? So different is force is different, yeah, tension is different in each spring. That's all. Okay, so the formulas are there in front of you. So the formula is P is equals to 2 pi root of m by k equivalent. K equivalent for this, for parallel combination, K equivalent will be K1 plus K2. Okay, so you need to remember this very simple concept, or all of you can do it, right? So that's all, my dear friends. Let's move to the next slide. Okay, so then on the next slide, I have written a simple question. Okay. So before that, I want to ask some questions from you. So let me see. I have a blank. Yes, this is a blank page. So I would like to ask a question. Listen, I have a spring having spring constant K connected with a block. Okay, so its time period is T1. Its time period is T1. Now, spring is cut into two equal segments, two equal parts, and connected connected in parallel. Connected in parallel with the same block. Okay, so the new combination will be like this. Okay, same block, everything same. So its time period will be T2. So find the ratio of T1 and T2. Find T1 by T2. This is a question. Okay, so this is very simple question. Find the ratio of T1 and T2. You need to answer. Okay, so let us solve it. Okay, so we all know one thing. What? KL is equals to constant. So K into L will be equal to K1 into L by 2 is equals to K2 into L by 2. So let us solve it. K1 will be equal to 2K and K2 will be equal to 2K. Okay. Yes. So this is what K1 and K2 we are getting, right? Means spring constant of this both the segments. Now what is the formula? So that is T is equals to, yeah, you know, T1 is equals to 2 pi root of M by K, and T2 will be equal to what? 2 pi under root of M by K equivalent. What is K equivalent? So that K equivalent is what? This is 2K, this is 2K. So for parallel combination, K equivalent is equals to K1 plus K2. So 2K plus 2K. So that is 4K. What? 4K. So I am putting the value. This is 4K. So we will get what? 2 pi divided by 2 root of M by K. So we are getting here what? We are getting here T1 by 2. What? You know, right? 2 pi root of M by K is T1, right? So directly you are getting what? T1 by 2. So directly I can say T2 is equals to T1 by 2. So means T1 by T2 is what? 2. 2 is the answer. Okay. So that's all. Very simple question. You just need to understand it properly. Okay. Just remember the formula. T is equals to 2 pi under root of M by K equivalent. Okay. Yes. So let me ask another question from you. So what is the time period of this system? So remember, first question I am explaining this. This is mass M, this is spring constant K. Okay. I am saying, let's say this is at equilibrium. This is at equilibrium. So I will say at equilibrium extension is X naught. What? Extension is X naught at equilibrium. So I will directly write downward direction mg and upward direction kx. So kx, okay, and spring force is always negative, right? So I am just writing here what kx is equals to mg. Kx is equals to mg. And now both are balancing each other. Kx upward, mg downward, so they are balancing each other. Next, if this block is displaced x downward. So I will say this is displaced x downward. So new extension will be what? X naught was already there and x is downward, right? So I will say simply x naught plus x will be final extension. So the upward direction is having some net force. So that net force in the spring will be equal to mass of the body into acceleration of the body. What is this net force? That will be what? K is spring constant, right? So minus K, and yeah, and that is x plus x naught. X plus x naught. So simply we will put this value. Okay. So this is minus. Yeah, this all things we got right. Okay. So after that, one more thing is remaining. That is what gravitational force is also there. So let us consider upward direction is positive. Let us consider upward direction. Yeah, you want to consider upward direction positive or negative? It's your choice. I'm just considering downward direction is positive and upward direction is negative. I'm considering like this. So here I will get plus mg. So total force is minus kx plus x naught. This is negative upward direction, right? Spring force upward. And mg force is downward. So mg downward and spring force is upward. Okay. So let us write its value m into a. That will be equal to minus kx is there. Minus kx naught plus mg. This thing I am getting. And you can see kx naught is equals to mg. So put the value here. So kx naught is equals to mg. This will cancel. So ma is equals to minus kx and I am getting A is equals to minus of K by M into X, right? So we can write it A is equals to minus of omega square X, right? So this is the formula of acceleration we used to get. A is equals to minus of omega square X, okay? Yes. So what is the value of omega? So omega is equals to under root of K by M. And what is time period? Time period T is equals to 2 pi by omega. So 2 pi under root of M by K, right? Okay. Similarly, we need to find the solution for this question. So how we can solve this question? So look at this. Here is a same system but in a different way. So here I will say simply this is mg, this is tension, this is tension. So I will directly say कि T is equals to mg and the same tension is delivered to the spring. Okay. So it means this is similar to this system. Okay. Similar to this system. Okay. No difference. So time period for this will be 2 pi under root of m upon k. 2 pi under root of m by k. Remember this. Okay. Okay. So this thing you need to remember. Apart from that, I am going to tell you a special trick. You will never get this trick. Okay. I am giving you a very special trick. It is not a proper concept. It is just a trick to find the answer. So I am giving you a trick. Remember, always consider K effective. K effective. That is called tension on the block divided by tension of the spring square, whole square, into K of spring, the spring constant of spring. This is the formula of effective K for a spring in any system. For example, this is the question given in front of you. So how you will write? Let us find the formula will be always T is equals to 2 pi under root of M by K effective. Okay. So this will be the formula. So let us find K effective. K effective we are going to find. Okay. So I am saying the block free body diagram of block tension T, right? Mass M. So tension on the block is T. Now the tension in the spring, so tension in the spring is also T. So I will say Ts is equals to T. Tension is same. So let us write it. So K effective will be T by T whole square into K. So I am directly getting a K. So answer is 2 by under root of M by K. Right. One more question I will give you. Okay. Now this trick will help you. Okay. Listen. Another question I am going to explain you. Listen. Very very important. Listen. I have one spring like this. It is attached with a pulley. Here is a string and here is a block. Okay. Spring constant is K. You need to find the time period of oscillation for this system. Okay. What is the time period of oscillation for this system? So as I told, at first you will write tension here. So this is tension in the on the block. That is what? At first you consider tension here T. So here also you will get the tension T. Okay, tension T. So what will be the tension at this point? So here tension will be 2T from the Newton's law. All of you know this, right? What is the tension on the block? Tension on the block is this 2T. Tension on the spring, that is only T. So let us find K effective. K effective will be equal to what? T blocks upon tension on spring whole square into K of spring means spring constant of spring. So let us put the value. What you will get? 2T divided by T whole square into K. So this will be 4K. What? 4K. So we are getting the effective K, that is 4K. Let us write the time period, that is 2 pi under root of M by K effective. K effective is 4K. Okay. So my dear friends, this is the answer for this question. T is equals to 2 pi root of M by 4K. So this was the short trick I wanted to explain you. Very, very important. You will never get this trick. Okay. So mind it. Now one more question I will ask you. Okay. So this is a simple trick you need to understand. Now the second question I am asking you based on the same trick. Okay. So look at this. I am erasing this. Okay. Shall I erase? So the next question is, one spring is arranged like this. Here is a pulley and here I am just drawing a surface and here is a block. Spring constant is K. So now you need to find the time period of oscillation for this system. So how you will find time period? है ना? Time period you need to find. So I will say time period. For that I am drawing tension T, and here will be tension 2T. So directly I will write what? I will write tension on the spring, that is 2T. Tension on the block, that is only T. You can see this tension on the block is T. Tension in the spring is 2T. Okay, so let us write the formula. K effective is equals to tension on the block divided by tension on the spring whole square into K. What you will get? You will get T by 2T whole square into K. So you are getting K by 4. What? K by 4. That's all. So what is the formula of time period? The formula of time period is 2 pi under root of m by K effective. So K effective is K by 4. So answer you are getting 2 pi under root of 4m by K. So I hope you are understanding it, my dear friends. Very, very important, right? Very, very simple concept. That's all. Okay. Yes. So one important question I would like to ask you. I have a spring mass system. Okay. Spring constant is K. Mass is M. So this is the simple thing, right? Simple arrangement for you. And it is given that its time period is 5 seconds. What? 5 seconds is the time period. On Earth. On Earth. So on Earth, its time period is 5 seconds. Now find its time period. Its time period on Moon. So find its time period on Moon. At Moon, how much time it will take? Okay. So what will be the time period of oscillation of this block on the Moon? So simply speaking, directly you will write what? T is equals to 2 pi under root of m by k. Okay, so it is just depending on mass and just depending on k. It is not depending on gravity. Actually, gravity on Moon is 1 by 6 of gravity on Earth. Okay, but no meaning. I will say the formula of time period on Moon and Earth will remain same. So time period on Earth is 5. The time period on Moon is also 5 seconds. That's all. This is the answer. Okay, so remember, the time period of oscillation of a spring mass system depends only and only on the mass of the particle and spring constant. That's all. It does not depend on any other thing. Okay. You go to Moon, you go to Mars, you go to Pluto, you go to anywhere. Huh? There will be the time period of spring mass system will be same. That's all. Okay. So you need to remember this basic concept. So that's all I wanted to say. Okay. So one more basic confusion NEET students used to get. So I am going to explain that. Listen. So let's say I have a spring and I have just attached this spring with a block. So I have a block of mass m. So I have just attached the spring with a block of mass m. Okay. And let us consider the spring constant is k. Spring constant is k. Okay. Now, yeah. So this is the basic system. It is given. Now, what happens? It is at net spring is at natural length. Natural length. If spring is at natural length means there is no extension. Okay. Now this block is brought down. The block is brought down. So here I am writing if the block is brought down slowly. Slowly means there is no change in kinetic energy. Okay. So slowly I am writing here. Brought down slowly. Okay. Then find. Then find maximum extension in the spring. Then find maximum extension in the spring. You need to find this. Okay. So simply speaking, remember whenever it is saying slowly brought down. So remember, you are just keeping your hand. You are just keeping your hand just below the block, and you are just bringing it slowly, so that there will be no change in kinetic energy. So there is no change in kinetic energy means it will just stay at equilibrium position. So finally, so a solution, finally it 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 stops at equilibrium. Okay, yeah, so it will stop at equilibrium, means there it will come to rest. So that will be the maximum extension. So directly I will say mg is equals to kx, and now let us draw its free body diagram. So equilibrium, so this direction kx and direct downward direction mg. So I will say this is k into x. Okay, the value of x is what? Mg upon k. So my dear friends, you are getting the extension in the string will be mg by k if block is brought downward slowly. Okay, very slowly I am bringing this block downward, then the extension in the spring will be mg by k. That's all. Okay, now the second question, if it is written that spring in its natural length, spring in its like natural length, mass is m, if the block is released released or dropped, or we can say uh, released suddenly. Okay, released, then find the maximum extension in the spring. So simply speaking, how to solve such type of questions? So simply speaking, whenever you drop this block, so suddenly it will fall down. So it will fall down, so it will achieve some velocity at equilibrium. So it will further go from the equilibrium to the maximum extension. So here maximum extension will be more. So how to use that? So you will use work energy theorem. So work done by gravity plus work done by spring, that will be equal to change in kinetic energy. So initially block was at rest. At maximum extension, block will again come to rest. Okay, this is x. So I am saying work done by gravity is mg into x. Gravity downward, displacement downward, so work done will be positive. Spring, so spring is extending, so work done will be negative. So half kx square. That will be equal to change in kinetic 0, because initially it was at rest, finally it will be at rest. So what will get? Mg is equals to 1 by 2 kx. So the what will be the final answer? X will be equal to 2 mg by k. So here you are getting the maximum extension. What? Maximum extension if block is just released. If block is brought down slowly, then only mg by k. Okay. Where is the equilibrium position? Mg by k. Okay. Right. So we will ask, what is the amplitude of the oscillation of the block? What will be the amplitude of oscillation of the block? So you will say maximum x max minus x equilibrium. If you will do that, that will be equal to amplitude. So we'll say 2 mg by k minus mg by k. So directly you can say mg by k is the equilibrium. Okay, or we can say it is the amplitude. Okay, mg by k is the amplitude for this system. That's all. This is a very simple question, and I hope all of you are able to do it, right? Then, so this is a simple thing I wanted to explain you. Now one more question I will ask. So let me see what is there at the next page. Yeah, these all things are, we'll cover it later. Yes. So here one more thing I wanted to explain you. So listen, one more important question with my tech. So how to write it? Listen. So simply speaking, we are going to draw a diagram and we will find time period for this. So let's say I have a spring like this. It is connected with a pulley. Okay, and this is going like this. Okay, and now here is a block, and here I am drawing another spring. Okay, so let's say spring constant k, spring constant k. So let us draw the tension. Let's say I am saying tension here is T. So here also tension T. So here also tension T. What will be the tension here? That will be 2T. Okay, how many springs are there? So 2 springs are there. So there will be 2K effective. So whatever springs are there, just assume that all the springs are in series. You don't know whether they are in series or not, but you just need to assume that they are in series. Okay, so how I'll solve? At first I will write K effective. So K effective is tension in the block divided by tension in the spring whole square into K. So let me write it. Tension in the block is T. Tension in the first spring. This is 1 and this is 2. So tension in the first spring is T whole square into K. So I am getting only and only K. Now K effective 2. K effective 2. So that will be equal to what? Tension in the block divided by tension in the spring whole square into K, because its spring constant is also K. So let us write here. Tension is 2T in spring and T in block. So T divided by 2T whole square into K. So what you are getting? You are getting K by 4. What? K by 4. Okay. So now how to find its equivalent? So its equivalent can be written like this. This is series. We will assume that this is in series. Such type of system we always assume that they will be in series. Okay. This is my special trick. As I told, only I use this trick. Okay. So let us find the equilibrium. So how to do that? So 1 by K equivalent 1, K effective 1 plus 1 by K effective 2. Okay. So I will write 1 by K plus 1 by K by 4. Yani ki 4 by K. So this is 5 by K. So what is the K equivalent? So finally K equivalent you are getting K by 5. What? K by 5. So now finally write the time period. So time period formula you know. T is equals to 2 pi under root of m upon K equivalent. So put the value of K equivalent. So 2 pi under root of m divided by K equivalent is K by 5. So finally we are getting here 2 pi under root of 5m divided by K. So this is the final answer for this question. Okay. So my dear friends, these are the basic tricks and basic formulas I wanted to explain you. I hope you are able to do it. Okay. So let us take one more question and solve it. So I am erasing this all and we are going to solve one more question. Okay. So look at this. So here is a block of mass m. Here is a spring. Here is also a spring. Here is also a spring. Here also a spring. So these are multiple springs. So this is K, this is K, this is K, this is K. Tension in this is T. Tension in this is 2T. Tension in this entire spring is T, 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 T. Okay. Tension in this spring is 2T. This spring 2T. This spring 2T and this spring also 2T. So we can say K, all springs are having same tension 2T. On the block tension is T. So I will write what? K effective 1 is equals to K effective 2, okay, is equals to K effective 3 is equals to K effective 4. All K effectives are equal and that will be equal to tension on the block divided by tension on the spring whole square into K. So tension on the block is what? That is just T. Tension on the spring is what? That is 2T. Okay, so what we will get? Just square it. Okay, so you are getting K by 4. What? K by 4. Okay, so now let us find these all are in series, right? I told you you have to assume it. Assume these all springs in series. So K equivalent is equals to 1 by K1 plus 1 by K2 plus 1 by K3 plus 1 by K4. These are four springs. So let us write. So I will write K by 4 for each, right? So I will write K by 4 plus K by 4. Okay, right? Are you getting? So this I am getting. So K equivalent, what you will get? 4 for 8 plus 4, 12 plus 16. So K by 16. Are you getting? So this is K by 16. So what will be the final time period? So T is equals to 2 pi under root of M upon K, K equivalent. So K equivalent is K by 16. So 16 will go up. So finally you are getting 4 will come out. So 8 pi root of M by K. That's all. So this is the final time period of oscillation for this system. Okay, beta. So that's all for today, my dear friends. So as I told you, this is very simple concept and all of you will understand this. You know? So daily I will bring 1 and 2 hour lecture for you, and I'm saying very important. I have very important announcement from Monday onwards. I'm going to bring the entire syllabus from kinematics to entire physics after that 12 class. Okay, so entire syllabus for you. on YouTube, right? And for that, questions will solve on special classes on Unacademy app. Okay, so entire syllabus you will get from Monday. Okay, so that's all for today. Let's move. These all things we'll cover today. Remaining things, right? So I just want to deliver 1 hour lecture today, and remaining things we will cover some other day, right? So simply speaking, everything is fine, and you will get to know and get to understand everything. So simply speaking, use my code RAHULD Rahul D, this code, okay, and get the 10% discount on what? On Academy subscription. If you are giving exam in 2021, then just use my code Rahul D and get the on Academy subscription, okay. And if you are giving my exam in 2022, definitely you should use my code Rahul D and get the Unacademy subscription. So, my dear friends, definitely it is very, very important for you if you really wanna crack NEET UG with us. Okay. So that's all for today. This lecture I wanted to deliver that much. Okay. And please click the bell icon and subscribe our channel so that you will get the notifications of our video and you can enjoy it. Right. So that's all for today. So any topic you want to learn from me, please write in the chat. Okay. And one more thing I wanted to say is we are going to start entire syllabus. We are going to start the entire syllabus from the starting to the entire syllabus, okay, on YouTube, right? When? From Monday. So that's all. So we are starting from kinematics. So that's all. Bye bye. Good night for today, my dear friends. Okay, that's all for today.